This is iFlight. Welcome to the tutorial video for the Commando 8 series. Before the tutorial, let's start with an introduction to the frequency compatibility of ELRS. The market offers a range of ELRS receivers with different frequency specs. It is essential to use a receiver and a TX module that operate on the matching frequency for successful binding. Using the Commando 8 as an example, it is offered in two single-band versions, 2.4 GHz and 900 MHz, and the newly upgraded dual-band Commando 8 Pro. Please refer to the instructions according to your device model. Following animate operation guide. Commando 8 2.4 GHz. It can bind to receivers with a 2.4 GHz transmitter module, including the 2.4 GHz receiver and the dual-band Gemini receiver. Commando 8 900 MHz. It can bind to receivers with a 915 MHz transmitter module, including the 915 MHz receiver and the dual-band Gemini receiver. The Commando 8 Pro, however, is a dual-band controller that can bind to all type of receivers, including the 2.4 GHz receiver, 915 MHz receiver, and the dual-band Gemini receiver. The following content will focus on the Commando 8 Pro remote controller. Binding and system menu introduction. Approach the remote controller. Short press, then long press, to power on. Short press the left 5-axis button to enter the system menu. Short press the right 5-axis button to move the cursor to express ELRS. Select the first option, packet rate, for binding. We need to select the corresponding packet rate based on the receiver type in order to bind properly. In normal state, the Commando 8 Pro has 16 packet rate modes. These modes are available in 2.4 GHz, 900 MHz, and dual band. The breakdown is as follows. There are 7 options related to 2.4 GHz, suffixed with 2.4G. Similarly, there are 7 options for 900 MHz, suffixed with low band. In contrast, there are only 2 dual band options, which are the ones starting with the letter X. If you are using an ELRS 2.4 GHz single-band receiver, we recommend choosing 252.4G for better performance in daily flight. If you are using a 900 MHz single-band receiver, we also recommend choosing 250 low-band. For long-range FPV flights, select downward to the 50 low-band mode. If your receiver is the dual-band Gemini, then the ultimate performance mode can be enabled. Select X150 or X100 full. After completing the above settings, navigate to Telem ratio by pressing down on the right 5-axis button. Here, set it to STD, the standard mode. Scroll down further with the right 5-axis button to access TX power. This is used to adjust the TX module power. The maximum power can be adjusted up to 1000 milliwatts. Feel free to adjust it to suit your individual needs. For daily use, setting the TX module to 100 milliwatts is sufficient. Let's keep this setting at its default value for now. Scroll down further with the right 5-axis button to access the bind option. Due to the time-limited binding window of the transmitter, it is advisable to first set the receiver into binding mode before pressing the bind option on the remote controller. After a successful bind, return to the main interface to view the signal strength indicators. At the same time, the receiver's indicator will change from flashing to solid on. Binding demonstration. Next, we will use the Nazgul Evoke F5V3 as an example for the following operations. The first step is to confirm what type of receiver is installed on the aircraft. After confirmation, select the binding frequency in the remote controller. Then, locate the flight controller, FC, tuning interface on the aircraft. Connect the flight controller to the computer using a USB data cable. Plug and unplug 3 times to activate the receiver's binding state. Note that the status LED confirms valid power, and you must wait for this illumination before proceeding to each subsequent plug and unplug action. The aircraft does not need a battery. Once all 3 cycles are complete, the LED flashing twice per second indicates the receiver is in binding mode. Also, you can locate the bind button on the receiver inside the aircraft. Using tweezers or a pointed object, press and hold the receiver's button. For 2 seconds, the receiver will enter a rapid flashing state and activate Wi-Fi mode. Then, long press it for another 2 seconds. Indicates the receiver has entered binding mode. The indicator light flashes twice every second. Press bind on the remote controller. Then return to the main interface. If the screen displays signal strength, and the receiver's indicator LED changes from blinking to a solid state, then the binding is complete. Binding with custom binding phrase. To enter binding mode, besides the standard approach of cycling the receiver's power 3 times, or, with the receiver powered up, enter binding mode by pressing and holding the boot button, we can also perform binding by setting up a binding phrase. What is the advantage of using a binding phrase? It allows the TX module and receiver to complete the binding process more quickly. In short, access the web menus of both the TX module and receiver. Set the same binding phrase in both. Power cycle both units to automatically complete the binding. What are the specific steps? Similarly, we will use the Commando 8 Pro to demonstrate the process. TX Module Settings. We'll start with the TX module. Short press the left 5-axis button to access the system menu. Select the Express ELRS option. Short press the right button to enter. Then, scroll down to locate the Wi-Fi connectivity option. Short press the right button to enter. Select the Enable Wi-Fi option. Short press the right button again. The TX module is now in Wi-Fi mode. Then, open the Wi-Fi settings on your electronic device. Find the Wi-Fi network with the SSID, Express ELRS TX. Enter the default password in lowercase. EXPRESSLRS. After a successful connection, the device will automatically redirect to the configuration page. ELRS Web Settings Interface. If the device has been paired with the TX module before, the password entry can be skipped. If the web page does not redirect automatically, then enter 10.0.0.1 into your browser, and press enter to access the ELRS Settings interface. Find the Option menu, scroll down to locate the Binding Phrase option, then can set the binding phrase. We can set the password to IFLIGHT666. After completing the above settings, click the Save button below, then click Reboot to restart and exit. Receiver Settings. Now, switch to the receiver side and power up the aircraft using a battery. Then, using a pair of tweezers, long press the boot button on the receiver for 2 seconds. The receiver enters Wi-Fi mode, with the indicator LED flashing rapidly. Then turn on the Wi-Fi option on the electronic device. Find the Wi-Fi named Express ELRS RX. Enter the default lowercase password, ExpressLRS. After successful connection, find the option menu in the settings interface. In the binding phrase field here, set the password to iFlight 666 as well. The above settings are now complete. Click Save below to save, then click Reboot again. Reboot and exit. After the binding phrase is set on both the TX module and the receiver, power on the controller and the aircraft to automatically complete the binding process. Computers, tablets, and mobile phones can all be used to configure the binding phrase via a Wi-Fi connection. Please note the following requirements for setting the binding phrase. According to the website's recommendation, it should be 8 characters long, consisting of numbers and letters. If the phrase is set too simply, other ELRS devices within signal range may accidentally bind to your system. For detailed information, please refer to the official ELRS website. Create model settings. After the remote controller is powered on, press the left 5-axis button to the right to enter the model menu. Press the right 5-axis button and downward to find a blank slot. Long press the right 5-axis button. Create model. After creating model, the name is set to default. If you need to change the model name, select the model with the right 5-axis button. Swipe right to find the second page, Model Name. You can set the name according to your needs. It will be saved automatically upon exiting. So, how to delete a model? Press the left 5-axis button to the right to enter the model menu. Press the right 5-axis button up and down. Select the model you want to delete. Long press the right 5-axis button to enter. Scroll down and select Delete Model. Click Delete. Click again to confirm deletion. It is important to note that, when deleting this model, must switch to another model option. To complete the deletion of this model, if you are currently on the model that needs to be deleted, the deletion operation cannot be performed. After the model is created, the TX module needs to be turned on. Swipe the left 5-axis button to the right. Enter the system menu. Swipe the right 5-axis button to the right to go to the second page. Scroll down to find external RF. Click the mode option. Scroll up and select the CRSF protocol. At this point, the TX module can be turned on. Meanwhile, set the baud rate below to 1.87 m. Click Confirm. After selection is complete, move the left 5-axis button to the left. Save and exit. Turn on the AUX channel switch. Move the left 5-axis button to the right. Enter Model menu. Press the right 5-axis button to the right to page down. Find the Mixes menu on page 5. Here you can see the main 1 to 4 channels. These represent the 2 stick control channels. Then, we still need to configure 4 AUX channel switches below, so that we can configure them in the Betaflight configurator. Set up ARM, angle mode. Scroll down to the CH5. CH5 is typically assigned to AUX1, which refers to the settings for AUX channel 1. It is usually set to the ARM mode function. For specific details, please refer to the official ELRS documentation. Short press the right 5-axis button. Enter the menu. Find the second option, Source. Short press to confirm. When the rear indicator starts flashing, move the switch you wish to assign. This will set it to the arming function. It can be configured according to your personal preference. Here, we select the one at the upper left of the remote controller, SWA2 position switch. Press the switch. The transmitter will now automatically detect the switch position. The flashing indicator will now become SA. If you happen to press an incorrect switch during the process, the system will recognize the error. You will then need to press the correct button again to proceed. After setting, Short press the right 5-axis button for confirmation. The position of the first arming switch on the remote controller has now been set. Continue with the setup for the next 3 switches, and so on. Let's briefly discuss ADC filter here. If you are using the Commando 8 to fly FPV drones, note that BF already has the RC filter configured. It is recommended that you do not enable the ADC filter option within the remote controller, as it will conflict with the existing RC filter on the flight controller. If enabled, it will impact the flight controller's PID algorithm. How can we check if our remote controller has this option selected? Return to the main menu interface on the remote controller. Long press the left 5-axis button to enter the system menu. Press the right 5-axis button to the right to page down. Go to page 6, Hardware. Scroll down to find the ADC filter option. Check if it is selected. If it is selected, then deselect it. Background and additional information. Differences between ELRS modes, modulation schemes. 1. LoRa is used for regular flight and provides strong anti-interference capabilities in complex radio environments. Its key advantages are the longest range and strong anti-interference capability. The primary limitation is that it only supports a refresh rate of up to 500 Hz. 2. FLRC mode is designed for racing flights, aiming for the ultimate response speed. Its advantages are the fastest response speed, support for high refresh rates from 250 to 1000 Hz, and the lowest latency. Its disadvantage is a shorter signal range compared to LoRa. 3. FSK mode is designed for racing flights, focusing on the pursuit of ultimate response speed. Its advantages include the fastest response speed, support for 500 to 1000 Hz high refresh rates, and the lowest latency. Its disadvantage is a shorter signal range compared to LoRa and FLRC. The following contains various introductions and notes on ELRS, such as packet mode, refresh rate, and frequency. You can take a screenshot and save it for future reference. We will not delve into each one in detail here. You can visit ELRS website for further information. That's all for this tutorial. Thank you for watching.